Welcome, Duke alumni and friends, to this session of the Duke Alumni Forever Learning Institute. I'm Ann Stephenson, Director of Professional Development for the Lifelong Learning Team in Alumni Engagement and Development Office. And I'm thrilled to have you with us today. Thank you for joining us for What AI Has to Do with Poetry, the second session in our FLI Computational Thinking series. Today, we're asking, what can AI reveal about literature? This session explores how scholars are using artificial intelligence to analyze ancient texts, identify poetic patterns, and rethink how we study the humanities. We'll have time for Q&A at the end, so feel free to drop your questions in the chat as we go. You'll also be asked to complete a brief survey before the session concludes. To help us explore this fascinating topic, we're joined by two Duke faculty members, Dr. Bhuwan Dhingra and Dr. Astrid Giugni. Dr. Bhuwan Dhingra is an assistant professor of computer science at Duke and a research scientist at Apple. His work focuses on making large language models like ChatGPT more trustworthy and efficient. He's held roles at Google DeepMind and earned his Ph.D. from Carnegie Mellon. His research is supported by major organizations, including the NSF and Amazon. Dr. Astrid Giugni is a lecturing fellow in the English department and the Social Science Research Institute at Duke University. She teaches and conducts research at the intersection of early modern literature, artificial intelligence, and digital humanities. Her work uses tools like natural language processing to explore texts by writers like Milton and Danye, as well as historical archives, bridging literature, ethics, and data. Please join me in welcoming Dr. Bhuwan Dhingra and Dr. Astrid Giugni to the Forever Learning Institute.
Thank you, Anne. So as Anne has kindly introduced me, I work in literature and in large language models for the exploration of early modern literature. So first of all, early modern means simply the 1500s and the 1600s. So I work with authors such as John Donne, Shakespeare, and John Milton. So what I would like to start with delineating today is really a question that is standard in literary research that deals with historical text. How do we know what a historical text means? How do we recover the meaning and context of something that was written 500 or 600 years ago? One of the ways that we do this kind of work is by diving into the archives. And by this, I simply mean that if I want to explore the meaning of a text by John Donne or by Niccolò Machiavelli, to look at an Italian author, what I would do is look at the letters that they wrote, the letters of their contemporaries, their writings, and as much information as possible from texts written at around the same time. I always, and every scholar does, obviously start with the surface meaning of a text. So essentially what words meant at the time, what the grammar might have been like. But to just get in deeper, I need to sort out how certain difficult or unusual words might have been used at the time. And in fact, a lot of words that we find familiar in our text might have meant something different 400 years ago. The past is a different culture, just as much as a different nation represents a different culture. Religious beliefs were different 400 years ago than now. Natural beliefs about the world were different 400 years ago than now. So what I might do when, for instance, reading Machiavelli's Prince and encountering the word state is wonder if he means a nation state, the way we might, which would be rather weird since he does not live it in a time when the current organization of a nation state was available to him, or if it meant something different, since it's a word that he uses quite often. For us, the word state probably captures a complex web of cultural, political, military, linguistic, and territorial structures. We might think of thinking of Machiavelli, Italy as a state. It has a certain language, a certain political system, and a certain geography. But when I look at somebody like Machiavelli, he uses the term to mean something a lot more sort of general, more personal to the prince who runs the state than something as specifically political that we might mean currently. Where we often see him saying about something like the majesty of his or her state, depending on whether it's a male or female monarch. So how do we recover this kind of information? Well, of course, part of it is simply, as I started to allude, by looking at a large numbers of examples. The larger, the better. But that presents its own difficulties and limitations. One of the examples that I will be working through in detail today with a poem from John Donne, a love poem, leads me to look at a set of documents that spans 4,000 pages in the 20th century edition. It would take a tremendous amount of time for any one given researcher and scholar to read 4,000 pages just to elucidate one poem or one document that we're interested in. Obviously, some of that work has to be done manually. But what I would like to hint at today is that by using sort of resources from OCR, optical character recognition, to AI that has been trained on early modern texts, we can actually speed up some of this work. So as this outline says, is that we want to look over a specific example of a literary text that has a different meaning that we do now. I'm going to show some of the archival resources and some of the obstacles that these archival resources present to the scholar. And then I'll work through a specific case of using OCR aided by a trained LLM to pull out some information from the period and then sort of go over how we will need to reintegrate this information in standard historical research. So let me bring up a specific poem by John Donne. It was written in the mid-90s. We don't know exactly when because he publishes it much later. And it's to his mistress going to bed. I've only put an excerpt of the poem because it's quite long and it is a rather bawdy love poem. So I'll just read what I have on the screen. Come, madam, come, all rest my powers defy, until I labor, I in labor die. The foe oftentimes having the foe inside is tired withstanding till he never fight. Off with that girdle, like heaven's own glistering, but a far fairer world encompassing. Unpin that spangled breastplate which you wear, that the eyes of busy fool might be stopped there. Unlace yourself, for thy harmonious chime tells me from you that now is bedtime. Off with that happy busk, which I envy, that still can be and still can stand so nigh. Your gown going off, and such beauteous taste reveal, and when from flowery meads the hill shadows still. I removed the long section, which goes on to describe the lady's clothing, which she should remove according to John Donne. License my robe in hands, and let them go before, behind, between, above, below. Oh, my America, my newfound land, my kingdom safeliest with one man's mend. My mine of precious stones, my empire, how blessed I am in this discovering thee. To enter in these bonds is to be free. Then where my hand is set, my seal shall be. So this is an early poem in the English language that encompasses the concept of America. the question that obviously I brought up is, what does the poem mean? Well, to a certain extent, it's a love poem. It is a timeless theme. I saw one of the questions pop up, and it's essentially about trying to seduce a beautiful lady from a young poet and to convince her to undress. But the comparison to America is obviously dependent on what we mean by America in the 1590s, or what John Donne and his audience could have understood by the term America. So after all, if I try to compare a relationship to a vacation in the Bahamas, I might mean one thing, but if I compare it to Mars, I might mean something very different about how thriving and pleasant that relationship is. So understanding the semantic field, so all the concepts that are connected to America in this time, helps us understand exactly what the import of this comparison, of this simile from John Donne, is doing for his audience. So how do we go about this? Well, I put some examples that actually help us track here. This is a map of the Western Hemisphere from 1596, so pretty much at the same time that the poem was being written, giving a sense of what the American continents would have been imagined like. So that looking at visual context can help us get a sense of the meaning of the term. But we also want to get a better sense of what kind of relationships between England, John Donne being a British poet, and the new continent, the new world would have been like in this period. We also want to understand what areas of America the English audience would have understood when reading John Donne's poem, and what kind of vegetation, geography, flora, fauna his audience and Donne would have had in mind. So what I'm going to discuss today is how we can start to get this information from a wealth of documents that we're lucky have survived since the late 1500s and the first quarter of the 1600s, which is the documents from the Virginia Company of London. I have about 4,000 pages of these documents that have been scanned and made available digitally. They span from 1606, and this is the founding charter where King James I gives a group of investors a monopoly towards trade and colonization of what they call Virginia in honor of Queen Elizabeth I, the Virgin Queen, and really spans modern day Virginia, North Carolina, and parts of South Carolina, which is what they would have understood as this area. The last documents that I have in this set are from surviving in 1624, when the company itself is under investigation and disbanded due to some financial improprieties by King James himself. So the goal of this research project is to use these economic, political, and management documents from the Virginia Company alongside narratives, essentially travel documents that were published in the period, to get a better sense for what the New World was like in the imagination of English people who had never been there. What did they say about ocean travels, about the indigenous people in the new land? The Virginia Company itself gave very detailed descriptions of the locations that they explored, of who they met there, what languages they spoke, what their alliances were, and of what kind of tradable goods, after all, it was a joint stock company trying to make a profit, you could extract from the land. So formally speaking, what I would like to do is turn the documents, and here I'm showing a manuscript version of it on the screen, into something that can be automatically studied through a process called NER, named Entity Recognition, which pulls out specific named entities. In this case, I've highlighted geopolitical entities and locations from the document, and allows me to track what is being mentioned at different points in time. So I could extract from it, is there a particular interest in the James River or the Chesapeake Bay in 1610 versus 1620? So what we need to be able to do this kind of work is to move from either manuscript or print documents into something that can be machine read. So that is the ideal format, but it's actually quite hard to automatically go from one to the other. I have here an example that is standard. This is a document from June 29th, 1622. And it presents the minutes of a meeting of the Virginia Company. Everybody who's present has been listed, and then we begin a transcript, which at the time was taken in shorthand and then transcribed at length, of the discussions for the day. When I put an image of this page through an OCR, optical character recognition algorithm, what I get out of it, it's something that is not particularly legible. As you can see, some of the problems are pretty obvious. The formatting of a table yields essentially nonsense, a list of numbers. And the fact that titles such as Sir and Mr. are abbreviated by S with a superscript R or M with a superscript R also trips up the OCR, which doesn't know what to do with it. This is a particularly good page to put through OCR, and the results are still quite difficult to work with. In even sort of worst cases, you might get pages that have been through time, since we're working with older documents, ruined by water damage, smoke damage, mold, creating it even harder to read for the OCR algorithm, and therefore produce a clean output. All right, so how can we handle this kind of text? Well, old school would be simply working with this output in a manual way, right? So I could sit down with my team, and I'm very lucky to be working with a group of undergraduates for the past few years here at Duke, and trying to find patterns through the errors of the OCR, and run through these patterns through a loop and present a corrected version, and have the sort of my loop run through all the documents and fix the patterns that I can recognize. That's obviously very time consuming and very likely to miss out a number of errors. But as Professor Dhingra will sort of explain in more detail, we can now actually leverage the fact that LLMs use context to learn the meaning of words, to make things a little bit faster, because we can actually use the fact that something like Chat GPT can be thought to recognize from both its background training, so the ability to look at the context and figure out the meaning of what is missing in the text, and a few examples that we feed to it in the prompt. That's something that right on whatever that string is, EA colon of Southampton really should be corrected to Right Honorable Earl of Southampton. In a sense, what we can train something like ChatGPT, an LLM like ChatGPT to do is very much the kind of context, sort of sleuthing out of a meaning that humans do. If you read enough early modern texts, you as a human being would immediately recognize what this is meant to stand for. ChatGPT can learn to do the same very quickly. It's not foolproof. Some cases are quite difficult, and I brought an example from my biblical citation, which is something that comes up quite often in early modern texts, where you might see something cited as John 5, period 39, period 7, period 38. Somebody who reads a lot of early modern texts will probably guess and assume that the most likely parsing for this citation is John 5:39 and John 7:38. But that is a guess. It's an educated guess, but we can't really know that for sure. And we can prompt an LLM to learn to make the same assumptions. But in my experience, it has been a little bit hit and miss with something that is disambiguous. And at the end of the day, frankly, an example like this is simply impossible for even an experienced scholar to fully determine, since it could frankly be a typo in the original document. Okay, so here's what we do when we are trying to feed the OCR documents to something like ChatGPT. Here I'm using the OpenAI API to train ChatGPT to do the kind of work that I needed to do. And as I mentioned, this was done and it's ongoing with students who in the summer work through Data Plus and during the school year work through Bass Connections. And what we do is, first of all, set up a set of rules. Just things that we know are typographical standards of the period. So some of you have taken Shakespeare, maybe when you were here at Duke, maybe familiar, of course, on Shakespeare with the long S. It looks like an F in writing, but it's really an S. So we can teach ChatGPT to recognize that. Ligatures are an artifact of handwriting where to keep the ink flowing in an old pen where you had to dip a quill into the ink, you wouldn't lift the pen, but rather smoothly move from one letter to the next. So that kind of orthographical change can also be taught to ChatGPT. We can also ask it not to translate. Here, I wanted to maintain Latin text, so I've asked it not to translate it into English. And then we feed it a number of examples that were created by humans, by the students and me working together, of OCR text and the way we want it corrected. And we ask ChatGPT in this case to read through the examples. Really, it was about 100. It's not that many. And learn the patterns of the kind of corrections that we want to see. And it actually turns out quite well. Here is the code running and the output rate when we feed in the text to ChatGPT of corrected material. To run through the full 4,000 pages took me about a week of constantly running the text through ChatGPT, but the results were extremely good. So here is what that might look like. Most of the text is corrected quite well. It's not perfect. But we can see, for instance, the example that I started with, where abbreviations of titles such as Mr. and Sir were really illegible. are now very clear. So we see Mr. Bland, Mr. Bull, etc. We can see that words that had been offset through some unusual maybe typography in the original text have now been corrected, that are straightforward to read. Some things were still missed. So we have the abbreviation of for Earl still for this particular example being left at EA colon rather than spelling it out. But that is a huge improvement. With the few errors that are still in the corrected text, we can either run another iteration with further examples, or we can simply sort of brute force hard coding a correction in our process in order to fix these problems. So what I want to leave you with before Professor Dhingra takes on from here is how we use these materials to understand meaning. And what I want to do is just bring briefly a quote from an amazing historian of the early modern period, that whatever intentions a writer may have, they must have been conventional in the strong sense. That they must be recognizable as intentions to uphold some particular position in an argument, to contribute to the treatment of some particular topic, and so on. It follows in turn that to understand what a writer may have been doing in using some particular concept of argument, we need first of all to grasp the nature and range of things that could recognizably have been done in using that particular concept in the treatment of the particular theme and at that particular time. That is a very clear statement of what it means to understand what something like America could have meant for John Donne, but it's something that requires being able to excavate a vast number of texts, something that scholars have been doing by hand traditionally for a long time, but can now be deeply accelerated through the use of something like this process of using ChatGPT to correct OCR output. And with that, I'll pass it over to Professor Dhingra. Thank you.
Thanks a lot, Astrid. Let me just share my screen. Okay, so I guess by now, I think all of us sort of recognize how powerful large language models are and how useful they are for all sorts of things, right? Ranging from humanities to, all different kinds of works that we do. For the second half of this session, I want to take a slightly deeper dive into understanding what language models are and how do they work. So let's start with a guessing game, right? Can you try to predict what the next word should be in this sentence? Could you please close the blank? Now, our common sense sort of tells us that, door, window, tab, these kind of words are natural next words in this context. But maybe something like bird or sky doesn't really fit the sentence here. Similarly, I think, we can take a lot of different sentences. And in each case, if I ask you, what should the next word be? You should be able to use some knowledge of language, how language works, and specifically in this case, how English language works. And also, combine it with some knowledge you have about the world, like what is the sun made up of, or what kinds of things do you finish up? And you should be able to come up with some reasonable predictions of what the next word should be in each of these contexts. Now, a language model is essentially the same thing, right? So it is a machine for predicting what the likely set of next words should be given a context. And believe it or not, but all of the major AI models out there today, ranging from ChatGPT to Gemini to Claude to the Chinese counterparts like Qwen, they're all under the hood language models. And this sort of holds true whether they're working over language, what we call language, or even if they're working over other things like images. So even when processing images, they tend to sort of break up the image into a sequence of patches and try to predict what the next patch might be given what they've observed so far. So when you enter a prompt into ChatGPT, and again, taking the example that Astrid presented earlier, the way that the model actually generates the response is that it predicts one word at a time, and at each step is trying to predict what the most likely next word might be. So given the prompt, a model like ChatGPT, it might first try to think of, okay, what is the most likely set of first words in a response to the prompt that has been given to it. It actually, under the hood, it ends up computing a set of probabilities for all of the possible next words. Based on that, it selects one word, right? So in this case, maybe that first word might be right. Then it uses that first word that it predicted, adds it on to the prompt that we gave it, and now tries to predict, okay, what is the most likely second word that might come after this whole sequence? And this way, it could go one word at a time from left to right and keep generating until it ends up with the entire response. Now, it might seem a bit remarkable that a model like this, which only does one word prediction at a time, how does it actually produce these really long, complex outputs which remain coherent throughout, which often have like a central theme, complex reasoning patterns, and really produce high quality text that we find it tough. That we find it hard to distinguish as whether it was machine generated or human written. But I think that's what separates a good language model from a bad language model. So good language models like ChatGPT, they tend to sort of plan ahead well in advance, right? So even before it generates the very first word in its response, it can sort of plan ahead to think about, okay, what the entire response should look like and how it should assign probabilities to the very first word such that the entire response ends up being coherent and reasonable. So that was like a very brief sort of intro into what a language model is, right? So it's essentially a next word predictor. Now let's think about the question, how do language models work? And to sort of explain that, we're going to take a step back. So we're not going to, try to cover the complexity of what a model like ChatGPT does, but let's maybe go back to the simplest kind of a language model that we can build, and that's called an n-gram model. So a sequence of n words is known as an n-gram. And what n-gram models do is that given a context, they try to predict the next word by taking only the last n-1 words in the context and using those n-1 words to predict the nth word. So if we have the context that I showed at the beginning, could you please close and let's say we are using a 4-gram model to predict the next word, then what the 4-gram model will do is it will only use the last 3 words in that context, and it will ignore anything that appears before those last 3 words. Now, to actually make predictions, what the n-gram model does is that it goes through a large corpus of text, and this corpus could come from anywhere. So it might be the collection of all the books ever written. It might be a dump of the internet. It might be a bunch of posts on a social media website, or let's say you're trying to build a historical language model. You might actually take all the texts that you have available from let's say the early modern period, and you might try to build a language model only for the kinds of language that you observed back then. But given a large corpus of text, what an n-gram model would do, and specifically what a 4-gram model would do, is that it would look at all the sequences of 4 words that appear in that corpus, and it will try to count how many of those sequences start with the 3 words that we are interested in, which in this case are please close the. Given all the sequences which start with these 3 words, it will then go ahead and try to count how many times each of the different words appears after these 3 words. And what it might find is that you typically find words like door, window, trunk following the 3 words that we started with. And even among them, something like door is maybe way more frequent and way more common than something like trunk as the last word or the 4th word after the first 3. So based on this counting procedure, an n-gram model would assign a very high probability to the word door as being the last word, and a lower probability to something like trunk being the last word, and a nearly zero or a 0 probability to a word like place being the last word in this sequence. Now, one thing that is worth noting here is that the size of the n-gram is actually really important. So let's say instead of a 4-gram model, if we had a 2-gram model, so a 2-gram model would only look at the last word in our context in order to figure out what the next word should be. And in this case, the last word is the. And if you look at any sort of large corpus of English, we would find that the list of words which follows this word the is quite different from the list of words which follows please close the. So you might find something like same, first, other. These are going to be the most frequent words that you would find in a corpus of English which follow the. And now you can notice that if we actually try to make a prediction just based on a 2-gram model, our likely set of next words doesn't really fit the whole context that we started with, right? So if we predict something like, could you please close the same, then that's really not a good completion to the context that we had. And that's why the size of the n-gram is really important. And a general rule is that the more context that you can use to make predictions, the better your model is going to be. So if you use larger values of n, you'll be able to make better predictions. But we end up with a different sort of problem if we try to increase the size of our n-gram model too much. So let's take the other extreme example, right? So let's say if we use the entire context, could you please close the, and now try to predict the next word. So now the problem is that longer n-grams tend to appear very rarely in any corpus that you might pick up. So for example, if for the exact corpus that you have, you might find that this exact sequence of words, could you please close the, this actually never appears in that corpus, but a lot of similar sentences might still appear. So you might observe something like, can you please close the door, or will you please close the window, or can you please kindly shut the door? So you might find a lot of very similar and related sentences, but nothing which really exactly matches the context that you had. And this sort of tends to happen more and more if you increase the size of your context a lot. So what we are missing here, and where sort of n-gram models, which are the simplest kind of language model that you can build, where they start failing is that they have no notion of word meaning. So we as humans, we know that could, can, and will, they sort of share similar meanings, right? They're very similar words. So if in our corpus we observe a statement like, can you please close the door, then door is actually a likely next word that we should predict after could you please close the as well, right? So in order to be able to make that connection, language models also need to sort of consider the meaning of words and how they relate to each other. So that's sort of the second idea or technique that I want to introduce here, which is how do language models represent meaning? Now, in order to understand that, let's again take an example, right? So let's say I show you this word, tesguino, and I ask you, what is the meaning of tesguino? Unless one of you speaks an Aztec language or you're familiar with Aztec culture, you probably don't know the meaning of this word, right? So you're in the same situation as a language model when it encounters a new word in a language that it's trying to learn. Now, let's say I give you a few sentences which mention this word tesguino. So the sentences might be, a bottle of tesguino is on the table. Everybody likes tesguino. Don't have tesguino before you drive. And we make tesguino out of corn. Now, if I ask you what is the meaning of tesguino after reading these sentences, I think a lot of you might be able to make the inference that tesguino is probably some kind of alcohol which is made out of corn, right? So the key idea here is that the meaning of a word is really given by the contexts in which it appears, right? So if I give you a lot of contexts in which a word appears, then you can figure out what the rough meaning of that word might be. So this idea is actually quite old, and it's influenced a lot of linguistics over the last few decades. And this is more formally known as the distributional hypothesis. And this was popularized back in, I think, 1960s by the linguist John Rupert Firth, who in one of his writings, wrote, and what is now a very famous quote, which goes as, "You shall know a word by the company it keeps." And it's really hard to overstate just how influential this idea has been in the development of natural language processing and also in the development of large language models over the last 10, 15 years. So one sort of concrete way that this idea is used in to automate, how we think about meaning, is in the construction of what are known as word vectors. So to illustrate word vectors, what I'm going to do is I'm going to construct the simplest kind of word vectors that we can. And in order to do that, I'll again take the 4 sentences that I presented earlier. But now instead of Tesguino, I'm going to put a blank in those sentences. And I'm going to consider 4 different words for which we're going to construct word vectors. So those words are going to be Tesguino, wine, tortillas, and loud. What we're going to do is for each of these words, we're going to check which of the sentences on the left does that word actually fit into. So we already saw that Tesguino fits into all of the 4 sentences. So under Tesguino, in that column, we're going to put a 1 in front of each sentence because Tesguino fits in each sentence. Now, for a word like wine, you'll observe that it does fit into the first 3 sentences. So it's valid to say a bottle of wine is on the table. Everybody likes wine. Don't have wine before you drive. But it doesn't really fit into the last sentence because we don't make wine out of corn. So what we're going to do is we're going to put a 1 in front of the first 3 sentences and a 0 in front of the last one. Similarly, for tortillas, the second and the 4th sentence is valid, but the first and the 3rd sentence is not. So we're going to put 0s and 1s according to that. And the word loud doesn't really fit in any of the sentences. So we're going to put all 0s in that column. Now, these columns here are the simplest kind of word vector that you can build, right? So they just consist of 4 entries, and they just consist of 1s and 0s. But already these word vectors actually let us, automatically reason about meaning. And one way to do that is by checking for word similarity. So one question that you might have, out of Tesguino and tortillas, which word is most similar or more similar to wine? And one way we can compute that using word vectors is by computing what is known as the dot product between the word vector for Tesguino and wine, as well as a dot product between the word vector for tortillas and wine. Now, in this case, the dot product is something very simple. We just count how many positions in the word vector do both the word vectors have a value of 1. And if we do that, then we'll see that Tesguino and wine, they share a 1 in 3 positions. So the dot product is 3, whereas wine and tortillas, they share a 1 only in a single position. So the dot product is 1. And based on that, we can make the conclusion that Tesguino is more similar to wine than tortillas. And that sort of agrees with our human intuition as well, right? About which of these 2 words actually has a more similar meaning to wine. And this is really the idea behind word vectors, right? So real word vectors that we have in language models, they're much more complex. They don't just consist of 0s and 1s. They consist of arbitrary numbers, and they're much longer. But the basic idea remains the same, right? So we try to use the contexts in which a word appears to construct its vector, and then we compare vectors by computing things like dot products over them. So, I've introduced sort of 2 very key ideas which go behind building modern language models. The first one is that of counting, right? So we can use very large amounts of data and count which things appear after which other things in order to make predictions. And that's what statistical language models do. That's the same for n-gram models, and it's the same for a model like ChatGPT. The other idea that I've introduced is that of using context as a representation to give an idea about meaning. And the way these models use context to compute meaning, that allows them to also generalize or adapt to new sentences or new prompts that you might enter that it never saw before. It can still sort of relate the meaning of the words and phrases that you give it to things that it has actually seen during its training. And these ideas are really fundamental to understanding how even modern language models work. But by themselves, they're not enough. So those ideas have existed in the field for a long time. But more recently, there has also been development of other things. And among them, the most notable thing to note perhaps is transformer networks. So most modern LLMs are based on what are called transformers. We don't have the time or the scope here to go into the detail of how transformers work. But I think the analogy that Professor Matt Hershey gave in the first session last week is quite appropriate here. So transformers are essentially machines for compressing a lot of data into something more manageable. They take the corpus that we give it as input, they see what all the counts are of how different words or different phrases appear with each other. They compress that into vectors, which represent meaning of different units of text, and they use those vectors to make predictions of what the next word should be at each step. And that's really a very high-level bird's eye view of how modern LLMs work. But one thing which is worth noting here is that in at least today, the race to build the best AI, there is a lot about how much resources and how much cost can you actually spend on building these models. So just to give you a rough idea of what modern models are built on, so they consume typically between 10 to 20 trillion words of text and hundreds of billions of images. In order to store the models and in order to compute with them, you would need anywhere from 10 to 50,000 GPUs. And another aspect that is often overlooked is that there's also several million hours of human supervision and human labeling which goes into these models. So if you just train a model on a corpus of text, it's likely to produce all sorts of harmful and unhelpful things as well. So you do need humans to sit down and sort of grade the responses that you get from models in order to sort of decide what is okay to show to users and what is not. So combining all of this, it takes anywhere from $50 to $100 million for doing one single training run of a state-of-the-art model. And some of the big labs like Google and OpenAI, they're actually running multiple runs of these every month per month. So it's really quite staggering the amount of resources which go into building these models. And I think it's still a bit of an open question as to whether the economic cost of that is really justified. And clearly the models are quite useful, but are they useful enough to justify this amount of spending? I think that question is still sort of a bit open. So that was a very, very quick run through of what language models are, how do they work. So coming back to sort of the title of today's talk, what does AI have to do with poetry? So now clearly, AI is a really powerful tool. It can read more text than a human or even a team of humans ever could. But the part that it's lacking is that it cannot really tell us why those texts matter, right? And that's where I think humanities come in. Humanities is the field which provides context to a artistic work, or it establishes the values by which we should be engaging with artistic works. So AI cannot really replace human engagement with poems, but it can help us put a poem in its appropriate cultural context, which is what Professor Giugni showed in the first half of the session today. So that's it for my part. And if there are any questions, we'd be happy to answer them.
Great. So we now have time for audience questions. If you have any questions for our speakers today, please put them in the chat. I'm going to go ahead and read the first one out. Let's see. Question I see is, in the writings, I think, Astrid, this might be for you. In other cultures than European, how does that inform your work? Was there writing in other cultures other than European?
So, well, part of it is my own work is Anglophone literature with some sort of input from Italian and French literature because of the nature of Renaissance Europe. So my work is being really focused on European languages, and it would require somebody who's quite fluent both with the culture and the linguistic background of another culture or period to include that material. However, one of the things that with my collaborator we're moving forward with is actually trying to see if we can understand how early modern English settlers understood the grammar of indigenous languages, especially of what they term, broadly speaking, the Powhatan people. They sort of misnamed a number of groups that they encountered. But they had some limited contacts linguistically with these groups through translators, usually children. And so they're trying to acquire this language. So that will be a step into the future for this particular project, but it require really careful linguistic immersion before we'll be able to do so well.
Got it. Yeah, that's very complicated, I can imagine. Let's see. If AI is just a weighted word predictor, will it foster advances in a modern to forward-looking environmental context? Or is that precluded by its backward-looking and predictive processes? Dr. Dhingra, I don't know if you want to take that one.
Yeah, I guess, I mean, that's an excellent question. I think it sort of gets to the crux of important research question that we don't really have an answer to, I think, which is that, so AI is trained to mimic human language, right? And any sort of responses that we get, as I tried to describe, they're the product of trying to look at human texts, human, ideas, and come up with new ways of sort of expressing those ideas and writing those things or responding to questions that people have. Now, does that process sort of lead to a real novelty or not, right? Like, can we actually train an AI to come up with new ideas and generate new poems? I don't know, honestly, the answer. I don't think, so there are, these models are definitely able to generate new language, right? They're able to express the same ideas in many different ways. Some of the ways that I think you may not find in the training data which actually went into these models. But at what point do you consider something entirely novel? At what point do you consider something, creative and artistic, which goes beyond what was fed into a machine? Clearly, humans are capable of that, right? So we generate new things all the time. But at what point do you say whether a model can do the same or not? I don't know the answer to that, and I think it's really not very well understood as to how capable these models are still in terms of advancing, any line of work.
Yes.
So just
Very
to add a little bit, another faculty member in the math department, Professor Rudin, Rudin, is actually working in trying to produce poetry through artificial intelligence. And having been a test subject, sort of a guinea pig for reading these poems, they're interesting. They're not what I would consider sort of original or sort of usual of a new poet or somebody I've not experienced in my readings before. So it's an active area of research, but at least from my experience in testing them, they're rather unusual.
That would be fascinating to read a generated AI poem. All right, let's take one more last question here. Bhuwan, can you explain against the 50 to 100 million cost? What is that for specifically? Maybe a few details.
That is the cost of building one instance of a state-of-the-art large language model. And by one instance, what I mean is that you go out, you get all the data that you want to feed into the model. You go out, you establish a data center with those 50,000 GPUs, and then you go through the process of feeding in that data into the model in one trial of feeding in that data into the model and building a product like ChatGPT. Now, in practice, obviously, building a product like ChatGPT, that involves trial and error. So you would typically do this whole process many number of times before you end up with the right recipe on how to do that. So, in practice, again, as I said, the big labs are really running this process again and again, every month to sort of improve the models and to make sure that they're building the best product that they can.
Yeah, that's fascinating. I think we have one last question, which I'm dying to know the answer to. I assume that by now AI has been used to analyze the writings of Shakespeare and Bacon and Marlowe to ascertain whether someone else wrote the plays. Do you have any comments on that, Astrid?
So I've actually haven't seen it done with AI. So there is been a number of experiments on specific works and specific poems, especially when there is a sense of maybe a collaborative effort using old school stylometry. So I'm sure there is an ongoing process. There has been something done on a particular work in Latin by John Milton that was rediscovered in the 19th century. The results just came out, assuming that it is indeed Milton's. But I think these are ongoing questions that really depend on how many comparisons to Milton's or to Shakespeare or to Marlowe's works we can bring in, because the ability of determining whether it's somebody's work, it's often dependent on how different it is from somebody else's, from another candidate. So I'm sure it's ongoing. The results are just not out yet.
Oh, so fascinating. It's been wonderful to spend some time with you both. Thank you for your time. Thank you, Bhuwan and Astrid, for a great session, and to our audience for joining us today.